Okay, so this video should be a lot shorter. I'm just going to go through the changes that we actually made to the code and review those quickly so that if I lost you in the previous video, you can watch this one and hopefully get those last little bits straight. I apologize, I don't type well. So we added 3 import statements. These import statements are specific for our input-output management. Paths is our helper class. We know it's a helper class because of that S. We're going to use this to provide a map or directions on how to find the file, essentially. A path from this code to our input file. We're importing the scanner class because that's how we're going to read this. It'll look very, very similar to what you've done with keyboard input as far as the methods we use and how we manage with the scanner. Very similar. A couple of little differences. But we're reading in text data, so a scanner is a nice, simple, familiar way to do it. We're also going to import the superclass for all of our input-output related exception types. We're good at the superclass level because there are a lot of subclasses. We're not going to try to treat the individual subclasses that could occur differently. We really want to treat all of them the same. So importing at this point is going to work for us. Dealing with our exceptions at this level in the hierarchy chart will work for us. Now, this is a declare only. We really didn't change this, but I like to point that out. This is a declare only. We're doing it globally just for simplicity. It's not good coding. All of this code through here was the same. Okay, getting ready to do the work, we built the regex, we built our pattern, we declared a string reference. That was all the same. The only thing that's really changed here, we're calling a method called openInput. We're going to build our scanner in that method. We're going to call the scanner we built readFile. That was our global declaration. Really, everything in here is identical to what we already had. We did add a close in this code. This was provided to you, and I am going to just jump on that soapbox again. Always close your files. Always close your files. Unless you're the sort of person who is perfectly content to walk out your front door to come to the university or go to work or go for a weekend away and leave your front door wide open. Unless that's you, close your files. Always close your files. So what we actually added was the openInput method. Okay. Now the throws clause with an S, remember from our exception handling, when a method could possibly, the method throws this exception. We have an active throw statement in the method throws this exception. We must have a throws clause. So inside our method, we're wrapping all of this inside a try block. Well, all is one statement. But this involves physical movement among your devices inside your computer. Okay, we're moving, in my case, we're moving from a USB drive through a number of buses. We're moving into core memory. We are referencing that core memory then through the JVM heap. That's a lot of physicality. Any of those physical functions could fail, hence the try block. We already declared the scanner, so what we're going to do now is instantiate it. The first thing that gets executed here, order of execution is always important. The first thing that gets executed here is the get method of the paths class. We pass to that method the full name of our file, including the extension, If the file were not in the same folder with our code, we would have to pass either an absolute or a relative path in front of this. Okay, you're familiar with how that works. What we're basically doing is helping to develop directions for the hardware to find where that file lives. Okay, that's what this will do. It will create for us an object of type path singular. That's the result of this call. Will be a path object that we then send to the scanner constructor. Internally, the scanner says, ooh, that's not a system keyboard you sent me. Okay, you sent me all the directions though. Let me double check this. Okay, and now I will set you up to read that very first piece of data. Here you go. You're ready. We assign that scanner then to read file and hopefully return to the main to process all of the data. In case something goes wrong inside of that, in case I pulled my USB drive out, my USB drive failed. Please, this shouldn't happen. My buses failed. My core memory chip failed. Oh my God, I'm really in trouble now. If any of that happens, catch the I/O exception. My recommendation is to always, if you're catching at a super level class, always find out the specific subclass. That's what we're doing here. Always get that specific subclass name because that can often tell you a great deal. Always extract the message. Sometimes the JVM really doesn't give us one, and that's unfortunate, but it is true. Try, ask. If you're doing input-output and anything goes wrong, always print your stack trace. Yeah, that can be a lot of stuff, but always print your stack trace because that's going to be valuable information. The last thing we did in this catch block was to say throw exception. This is what we call a simple rethrow. We can't add any data. If I had any new information, I would chain this exception. I would chain this exception. I would be building a brand new I/O exception object based on the current one plus this new data. I have no new data. I guess I could wrap, if I put this in a string object, but if I have any sort of message, it's going to provide that back to me anyway. So there's really nothing I can add. I'm going to do a simple rethrow. That's the end of my catch and therefore the end of my open input method, which was really the bulk of what we wrote in the previous video. Now, just for fun, I'm going to go ahead and execute this again. And that was 40 test cases. You can count through them. And we've got a message for each of them. The red ones are not valid. The green ones are valid in terms of structure. What I didn't say previously in chapter 14 or the previous video for this chapter is that there's a lot more to zip code validation than just 5 digits or 5 digits followed by a dash followed by 4 digits. We're not going to worry about the deep dive on that. We're just looking at this in a sort of cursory fashion. Okay, that was a recap of the changes we made, and thank you.